Last time we were here, we were testing rockets made of gummy bears, and the results were spectacularly unspectacular.
Round two.
We had rockets that did this,
Oh, no.
and rockets that did this. A duck. Yeah, so we've changed our methodology entirely. We've gone from hybrid rockets to solid rocket motors, and we've come back out to this site with a gummy bear rocket to test. We've also come out with something I might call Heinemanian.
Horror within horror.
Mr. Heineman has gotten a bee in his bonnet about making a rocket using poop, and we are also going to test that.
Last time we saw the sweet and sour fuel, they were powderized and sent off to the rocket scientists.
And here is what they did with them. They turned them into two official rocket motors, one made out of gummy bears, one made out of poop. Barely worse than the gummy bears.
Yep, they've been converted into solid rocket propellant.
It looks like this. Basically, it's composed of an oxidizer and the fuel, which is held in place by a binder made up of a variety of rubber resins. Now, when that starts to burn, all those expanding gases are forced out through the rocket nozzle. That accelerates those gases, creating a lot of thrust, and up the rocket goes.
In stark contrast to the hybrid system, it couldn't be simpler. An electronic match is lit, and in theory, the gummy and poop-based fuels begin an explosive chain reaction. Question is, how will the mythical fuel's performance be measured?
It's almost time for launch. Now, our first launch is surprisingly not going to be either a gummy bear rocket or a poop rocket. It is, in fact, going to be a control launch of a best-case scenario rocket, otherwise known as a rocket. Big rocket coming through! It has the ideal mixture of fuel, binder, and oxidizer.
Okay, in goes the engine with standard rocket propellant.
And it will give us the best-case scenario of how high a rocket can go of this size and weight.
All right, well, that's it. Let's put it on the rail.
All right. Now, I know we've already spent a bunch of time explaining the difference between this rocket and its predecessors, but you might not notice. We've got 3 cameras attached to this rocket so that we can see the rocket's eye view of its own launch. That's pretty cool. Oh, yeah, I remember. This part sucks. There we go. She's up. All right, you ready?
I'm ready.
Okay, here we go. Mythbusters solid rocket motor control in 3, 2, 1. Yeah! I knew we'd see a rocket fire eventually. That was cool.
Yeah.
A little pop, that was the pop of the parachute deploying.
Unlike the hybrid system, the ignition and launch was successful. And the rocket's eye view of the Mojave Desert, spectacular. However,
Oh, and it's drifting. It's drifting a lot.
proving once again that rocket science is, well, rocket science, wind conditions were less than ideal.
All right, let's go get our rocket.
During ascent, the rocket was pushed significantly sideways.
We might be wandering here for a little while.
But after a successful search and rescue, they head back to base, where they discover it reached 4,133 feet. But more detailed data reveals a potential problem.
So we had a good launch, but the telemetry and GPS is telling us that we had a lot of lateral drift that may have compromised our data. Because if that curve was straightened out, it might have actually given us